All right, thank you for joining. This mic is on. All right. My name is Tony Opferman. I'm from Rohde and Schwarz. We're a test and measurement company based in Munich, Germany. And today I'll talk a little bit about characterizing IoT device performance. So what sort of things you need to be aware of to ensure your device is performing. So people always ask, why do I need to bother testing these IoT devices? They're only, $10, $15. What's the point of testing this? And I use this analogy where, you have these $2 or $3 latches that you're counting on for your life. And of course, there's testing done to ensure these latches don't break. So it's somewhat related to IoT, maybe not a life or death situation, but it is important that you do testing for a monetary point of view. So if you have deployed thousands of these IoT devices in a parking garage, and you later find out that the concrete isn't allowing some of the RF to penetrate properly, and you have some issues with the antenna placement, that's going to cost a lot of money to go in and replace thousands of these IoT devices. So just because the one little IoT device is only worth $15, there's still a bigger picture behind that in terms of what happens if you don't do enough testing, what happens if your performance isn't where it should be. It's going to cost you. So testing is critical. And I think some of the gentlemen up here were talking about service assurance, and it all goes back to how well do you test your device. Some of the challenges that I see in this space are technology choices. What sort of technology do you want to put into your device? Bluetooth, wireless LAN, Zigbee? Well, it depends on the use case. How much data are you going to need to be transmitting? What sort of range do you need? So you have to factor in the use case for your IoT device before you make a technology choice. And the design complexity is another challenge. Do you choose a chip on board approach versus a module approach? How do you go about designing your IoT device? Certification, what's important for certification? What type of certifications do I have to go through? Am I getting my device into a carrier? What sort of testing do those guys require? So just understanding the certification process is quite a challenge. And then making sure it's a highly reliable device. So making sure that the battery lasts up to 10 years, making sure when it's deployed in a Verizon or AT&T network, it behaves as it should. It connects to the network properly, and it's not constantly trying to retransmit data that it shouldn't be. So these are some of the challenges that I see in the IoT market. When it comes to performance, I see 6 different areas that people should pay attention to. Battery life testing, OTA or over-the-air testing, making sure your antenna is properly placed in your product, making sure that the casing is not causing any problems. I was talking to a gentleman from 7 Layers, and they were testing some IoT device that was embedded in a door, and he said, it wasn't, the RF was failing because of the type of material used for the door. So you really have to be aware of what material you're using and how does that impact your RF performance. And as you build these devices, another impact is, you have so many technologies in there, and they all compete with each other in terms of spectrum, especially this ISM 2.4 gigahertz band. You have Bluetooth, wireless LAN, Zigbee, they're all operating in this space. And so there's a lot of coexistence issues when you have a product that's transmitting all 3 or 4 of these different technologies at the same time. How do these technologies interfere with each other? So coexistence testing is another area of performance that you need to focus on. And then I mentioned the carrier testing. These guys all have their own set of tests. Verizon, AT&T have a specific set of tests for their IoT devices. So you have to ensure you pass those tests as well. And then security is something that is a hot topic. And the last bit is the data transfer. How's the data getting transferred? Is it reliably getting to the other end of the network? Are you having to retransmit too often? So these are the 6 different areas that I see you need to focus on when it comes to performance. And since I only have about 15 minutes, I'm just going to touch on these 4 briefly. And we have a booth just next door. If you want to swing by the booth and ask some more questions afterwards, if I go too fast, feel free to stop by. So first one is battery life. Within these IoT modules, you have all these different modules, the sensor interfaces, wireless chips for the different technologies, your power management unit, the processor, the memory. So in testing this IoT device, battery life is probably one of the top 3 priorities because it's deployed in these far off spaces out in fields for agriculture testing or throughout different parking garages, and you don't have to go replace these batteries. So battery life testing and ensuring the power consumption is what it should be, power integrity is clean. Ensuring these 2 things are critical for your IoT device. When it comes to testing that, we have some products out there today which you could hook up what we call our CMW 500, which is essentially a base station emulator, and you could emulate a real life situation. So you could emulate a Verizon network, for example, with fading conditions and see how the battery performs. Maybe you do some handovers. Maybe that one doesn't quite apply to IoT devices, but fading conditions, you could simulate the Verizon network and see how the battery performs. So with this product, we have a probe which you could monitor up to 4 different areas within that IoT device, and it has an accuracy up to at the nanoamp level. And what this product does is it'll look at the power consumption over time, and it'll compare that to the different type of signaling that's happening. So as you attach to a network, for example, you'll see power consumption probably spike during that signaling phase. So you could really correlate the power consumption back to the behavior of the device. Why is the power consumption so high at this point? You could go back and look at, okay, here's what the device was doing. It was setting up a data connection, and it was constantly having to retransmit data for some reason, and you saw the power spike. So that's a product that we're actually displaying next door here. The next point is OTA testing, or over-the-air testing. So making sure the antenna is placed properly, making sure the casing is correct. And what we do in this case, it's called over-the-air radiated test. So the goal of OTA testing is to characterize a wireless device performance with well-defined standards. So there's some standards bodies out there like CTIA that are defining these OTA tests. So it's important that you run through these tests with your complete device, including the casing, the antenna placement, and making sure that the antenna is performing as expected. So why bother performing these tests? Like I was saying before, it depends on the casing that you put around the product. That casing could have different RF impacts on the device. So it's important that even if you just take a module from Gemalto and stick it into some casing, it's still important to go through and validate that RF performance is what it should be. These are the different organizations within the OTA market. So I mentioned CTIA. They have a group of people that go off and develop these test standards for OTA. And then, of course, you have all the vendors out there like Apple, Intel, Samsung. They all go through OTA testing. And then the carriers themselves have their own set of over-the-air tests. In fact, I think Verizon has their own OTA test plan for IoT devices. And then, of course, the certification labs like 7 Layers, PC Test, Intertech, those guys all have an OTA set up in their lab. And so at a high level, what you're doing is you're taking the device and moving it in a 360-degree fashion and measuring the transmit power, and then you're also measuring the receiver sensitivity. And you're moving the device around in such a manner you're able to monitor the RF performance across the whole device. So there's 2 main tests, total radiated power. So again, you're moving the device every 15 degrees, you move it and then take a measurement. You're telling the device to transmit a certain power level at a certain frequency at each one of these points, and then you measure it and compare to what it should be transmitting at. And then the TIS, or total isotropic sensitivity, this is a receiver test. So the base station or base station emulator is transmitting data down to the device, and you're measuring the block error rate or packet error rate at a certain transmit power. So you're making sure that that receiver is performing where it should be. So these are 2 very basic fundamental tests that all IoT devices should run just to ensure that, again, the casing is put together properly, the antennas are properly spaced apart, and this will catch 90% of your RF performance issues, just these tests alone. And I bring this slide up because you'll see some of the different technologies like LoRa and Sigfox have a very low receiver sensitivity, up to 100 or down to 140 dBm, very close to a GPS receiver. So these are very sensitive devices, and it's important that you test that those are truly capable of receiving packets at that low level. And this is a standard setup for doing over-the-air tests. It's just this small chamber we have called the DST200. You put your device in there, you close it up, and then you have a rotating mechanism in there to move the device around. And then the instrument at the bottom there is our base station emulator generating the RF signal into that casing. So it's a true over-the-air test versus a conducted test where you take an RF cable and connect it up to the antenna. So this is a setup for an OTA system, something that you would find in most R&D labs. So this one is talking about coexistence testing. I mentioned before, many different technologies go into these devices, and a lot of them use an unlicensed spectrum at the 2.4 gigahertz. So it's important that you test how the device performs when it's transmitting multiple of these technologies simultaneously. And I think there was an example with Google Nest is a device that has LTE in there, it has Zigbee, it has wireless LAN, I believe it has Bluetooth, and there are times when the hello? Okay, there are times where that device is transmitting all those technologies at one time and it causes problems. So we need to test the coexistence across those different technologies. So as you can see here, this is a typical IoT device, many different technologies, and coexistence exists between those different technologies. An example here I show is between LTE and Zigbee or 802.15.4. There's some overlap in the frequency spectrum there, as well as Wi-Fi and LTE. At, I think, band 41 and band 7 in LTE, there's some overlap with wireless LAN. So you need to test how those technologies interfere with each other. And to do this, it's a very simple setup. Again, we have a shielded box, and you're bringing in multiple technologies. In this case, we're showing LTE and wireless LAN simultaneously being put into the shield box, and we're measuring some data performance to see, okay, when you're transmitting data over LTE and then you bring in a wireless LAN signal, how does that degrade the LTE data performance? And then the final one is performance around the different carriers like Verizon, AT&T, and Sprint. And this is important because those carriers have different test requirements that are specific to their network. A couple examples, I know with on the Verizon network, there's issues with their devices constantly trying to retransmit and get a data connection on the network. So it's going through this whole data retry process, and it's just in this loop where it's trying to access the network. And there was a case where there were some devices out in the field and the battery was lasting less than a couple months, and they couldn't figure out why. And later they found out that, okay, the RF performance of this device was very poor, and it was trying to connect up to the Verizon network and going through this whole data retry process. And in doing that, it sucks the battery because all the extra signaling involved in generating those messages just drain the battery. So there's very specific test plans for the carriers that they come up with themselves, and it's required for IoT manufacturers to run through if you're wanting to go on their network. And just an example, I was working with a company that develops a home security device, and it has LTE and many other technologies in there, and he wanted to bring that product onto the Verizon network. Well, he ended up choosing to use a chip on board approach where that chip had not been certified in the Verizon network versus maybe grabbing a Telit or a U-Blocks module that had been certified by Verizon. So he went through his whole design, brought in a new chip, and went through the whole chip on board process. And it took him 6 months to go through the whole Verizon validation for that particular device. Looking back, he said, I wish I would have went with the chip or the module-based approach where Verizon had already certified a U-Blocks module, and I could have just plugged that into my home security device, and I would have breezed through all the Verizon tests. In fact, you end up skipping a lot of the Verizon tests since it's already certified on the module. So, there's a lot to be tested when it comes to getting into a carrier like Verizon or AT&T. So making sure the device performs to their standard is also very important. And with that, I guess any questions? No? Nice quiet audience. Well, I guess we're getting ready for happy hour, so you're anxious to get out of here. How'd I do? Maybe a little bit over. All right. Great. Thanks a lot.